In today's video, we're going to talk about mathematical proof by induction. So this is a very rigorous way of proving by induction. So there are a few steps that we need to follow while doing a proof like this. So the simple question right here is to prove that 1 plus 2 plus 3 plus all the way to n is equal to n plus 1 over 2. So this is the for any n that is a integer, a positive integer, let's say. So for something like this, we need to first establish a proposition. So our proof will look something like this. So we need to first say, let Pn be the proposition that, so for all the left-hand side, we can use a sigma notation to denote it. So from 1 to, let's say, k, and with summation, all the n's will be equal to n, in this case, we will just use k plus 1 over 2 for any k that is a positive integer. Now we need to first establish a base case. So in this case, we will do P1. So sigma n is equal to 1, 1, n will be equal to 1, and 1 times 1 plus 1 over 2 is equal to 1. So the two sides are equal. So because summation n equals 1, n is equally 1 plus 1 over 2. So P1 is true. Next is the induction step. So do the induction, we need to say that suppose Pk is true for some k that is, again, positive integer. So we will have summation n equal 1k and is equal to k times k plus 1 divided by 2. Now we add k plus 1 to both sides. That is the next term in the sequence. On the left-hand side, we will have n is equal to 1 to k plus 1, n is equal to k plus 1 times k plus 1, 2. This will be 2. So therefore, if we just multiply that k plus 1 onto the numerator as well, we will have something like this. Just to make it abundantly clear, we will rewrite the left-hand side just a little bit. So it will look like k plus 1, k plus 1 plus 1. Say square bracket to make it abundantly clear that this actually resembles the k plus 1 over 2 model. So therefore, so we will say Pk will imply Pk plus 1. So since P1 is true and Pk, any Pk implies Pk plus 1, which means P1 will imply P2, and which will imply P3, and so on and so forth. Pn is true for for all. Actually, we can use the symbol for all n that is a positive integer by mathematical induction. and QD, or we can draw a square here. So this would be how we use a mathematical induction to prove this question right here. So again, we need to have a proposition statement right here, and then a base case establishment, and then a induction step to finally achieve this critical statement right here, and then the concluding statement, and then some indicator to show the audience that we are finished. I hope this video helps you understand how we can conduct a mathematical proof by induction. Thank you for watching.